name is Srinivas. I am working as assistant professor in IRE college. In this session, we'll talk about the SQL Server review in terms of software development cycle in the terms of SQL Server. This will be at high level. Okay, we'll talk about SQL Server in terms of installation, then the process of using the software development life cycle. Okay, that all we'll be discussing in these slides. Okay, this will be the starting slides. Okay, now now you have a database. There should be some person to administrate the database. If the database is not taken care of, it might collapse. It might collapse. It might there might be the space might be over. So what's happened when your system server has no space, you can no longer add data. Okay, you can no longer add data. Now there should be a person who need to take care of your database. That person name is the SQL Server administrator, or called DBA, database administrator. So DBA is a person. DBA as database administrator is a person who is going to take care of your database. Now, what would be his roles and responsibilities? What would be his roles and responsibilities? Okay, he is going to a person who is going to install and configure the SQL Server. When I say install, means that he will install the software and he'll also configure. What does this configure means? In this configuration means there could be how many databases would be there, how many users could be there, how many temporary databases could be there. These are all will be his responsibilities. Then he also should plan and create the databases. So on the server there could be many databases. For example, there could be a student database, there can be a faculty database, there could be one library database, there can be a transport database. There will be many databases. So his responsibility would be to plan and create databases, and he has to take the backups of the databases. Okay, on this backup means something happens to your database. It's getting corrupted. That means that you have lost all your data which you have been trying to save all these years. You have been suppose this college is there to some year 2000. The 20 years data is there with you. Something happens to the database, your entire data is gone, right? Again, you cannot go and create all those once again, right? So you have to take the backup of the database. These backups have been taken very, very regularly. So again, it depends on your how frequently your data is updated. So this generally the backups are taken every week. Every week they'll take a full backup. So this Monday, this is the Monday, Monday to Saturday, they will take the full backup, and they also will take the incremental backups. What is the incremental backup? What has been added since yesterday to today will be added here. What has been added since yesterday to today will be the incremental backup. So every day this increment backup will be done, and every week or month or year they will take the yearly backups, monthly backups or daily backups. Now there might be some highly transactional things like your bank accounts where your data gets frequently changed. At this point, you have to make your backup things. Is also responsible for responsible for restoring the database when necessary. He is also responsible for restoring the database when necessary. He setups and manages SQL users. Now, okay, all users, there might be some 100 users in organization. All will not have the same rights. Only your faculty will have the rights to update your marks, whereas as a student you have rights only to use the data. As a student you can only view the hall ticket, or you can only view your marks. You cannot update it. Now this all is done by your administrator who gives you the permissions to add or update data. Okay, He also manages security for new users and existing. He also manages security for new users and existing users. When I say existing users, suppose you're a user, you have only the read-only rights. You cannot write the data. Suppose if you're adding a new student, then based upon his privileges, his data will be there. Then import and export data. Import and export data. That means that you can export your data to somebody else, or you can take somebody else's data and insert into database. For example, I have my suppose I'm merging two colleges. See, IR is there, and now beside there is one more college, Mari Lakshman College. We want to combine these two data. They are going to give your data to you. You will import to your database. You will make some changes to their thing and you will import. Similarly, you want to share your data with somebody. You can export your data also. It also it also setups manages task alerts and operators. So what is the alert? Suppose that he's going to create an alert on your database saying that if your database is getting overloaded, he'll inform the user saying, he'll inform your principal saying that my hard disk is getting full. Please provide me a new hard disk. Okay, and also he manages the replication environment. What is this replication environment? Mentioned copying data from one server to another server is a replication. Again, there are three types of replication: snapshot replication. Then you have merge. You also have the transaction replication. So replication is a mechanism to copy data from one server to another server. Okay, turn the SQL server system for optimal performance. Okay, he'll be analyzing your database objects. He'll see that if something is slowing down, where something has to need to be improved, then he is going to take that remedial measure. Suppose you write a procedure which is taking too much time to execute it. Suppose you have a procedure in that you have complex logic is there. There you are trying to make it. Then this time this will work. So he is going to take care of those things. And he also troubleshoots any SQL server problems. Suppose you say that I'm not able to connect to my server, then he is going to step in. He'll see what is that it is not allowing you to think. So these are the various responsibilities of the SQL Server Administrator or DBA. Okay, now he'll see here. What are his duties, DBA duties? So he does the user management. That means creating users, and managing those users. Okay. He also audits the data. He takes the disaster backups, disaster restore backups. He takes the disaster restore recovery, archiving. Suppose there's old data which is not frequently used, then he will archive those records. He will archive those records. He also does the security, and he also fine tunes. Suppose there are some procedures taking a lot of time, then he's going to fine tune your queries, and also he is responsible for data management. Okay, these are the various administrative duties which a DBA does. DBA is database administrator. Okay, now we'll see what does he does actually each one of them. Installation. He does installation, administration, and maintenance of SQL Server instances installed in SQL Server. Okay. Then he also suppose after that now he also set up a test, dev, staging, and production environments. Okay. What does this means? What does test means? Where you perform your testing. And dev is that where you develop your application. Suppose you are developing an application, it is not development. After development, you are going to take it and give it to the testing team. So testing team will test and give you bugs. Once it is bug free, then you keep on the staging server. This is the staging server means before going to the production, that is actual release, your data will be tested by the end users, or the beta testing by the actual users on a staging server. Once they feel confident that this is working as per their expectation and it is bug free and there are no issues involved, then it is your code is shifted to the production environment. Okay. Then he's also responsible for creating users and assigning permissions based on the level of database access the user could need. Suppose you are you're only a viewing. You're only a view, like for example, student will only view the data. He can modify. Then he'll be giving only the read only permissions. Similarly, if the same if I need to give him also the updates to insert or update the things that is faculty would update or insert his marks, then you would be having the some more higher rights. Then create linked servers to SQL servers, now, other databases as Oracle, Access, Informix, etc. Security and General Administrator. Design database backups and restoration strategy with data backups and SQL Server agent. So, what does this backup means? Your data, which is getting every day added, needs to be taken care of. Something goes wrong, then he takes up backups on frequency on a frequent intervals. That those intervals could depend on the how complex, how important your data. Suppose you are dealing with an online banking system, your every transaction is important. Then it is every hourly or every half an hour your backup will be taken. Suppose in the case of student, that means after first year, so generally you will not be adding new student. Then every week you will not be adding new data. Only at the time of admissions you'll have new data, and at those cases you don't need to take backups very frequently. Okay. Now, also once created a database, backups, monitor these backups are being performed regularly. So he will write some scripts on the back end to take the backup of every DB. So again, these backups can be taken on incremental or full backups. When I say full backup means entire data copy will be copied. So I have a DB with 10,000 records. Same this 10,000 records data will be copied to the new server. However, if suppose I don't want to copy the entire thing because I daily I add only one record, but my DB is there for 10,000. Daily I'm adding only one record. So why to again every to take the entire 10,000 records? So I'll add only the new changes. That is called as incremental backup. That is called as incremental backups. That is called as incremental backups. From time to time to recover databases to specific point of time as per request. Suppose your database is corrupted, you have up to the last backup. That time is going to restore. Then set up high availability as part of disaster recovery strategy for the databases. Failover clustering, database mirroring, and log shipping and replication. So, for example, for database mirroring, log shipping, replication means when you come to the replication, your data will be at every instance will be replicated to the other server. So there will be some other servers at different points. So your data will be replicated. If something goes wrong with the main server, immediately this is put off. That server will be put online. Then troubleshoot various problems that arises in a day-to-day work and fix the issues. Monitoring SQL Server logs and checking your email alert is configured. Then he also monitors and performance tuning, physical server level, database level, query tuning. So creating indexes. Suppose he sees that your database is taking a lot of time to give the output. Then he might think of creating some indexes. So what are the index is going to make your data come faster. Okay, these are the and applying any new patches, any new patches. This all will be the SQL Server administrator duties. Okay, now we'll see about the things. The relational database management system. RDMS means the relational database management system. RDMS data is structured in database tables, fields, and records. Each RDMS table consists of database table rows. Each database table contains one or more database fields. So a table. So RDBS means relational database systems. Means that your tables all will be in relations. So your data is structured in tables, fields and records. A table will have fields and records. Each table will have some rows if there's any data is there, and each row will be a unique record. So RDMS stores the data into collection of tables which might be related by common fields, database column names. RDBMS also provides the relational operators to manipulate the data stored in the database tables. Most RDBMS use SQL as a database query language. So SQL is nothing but structured query language. This will be the language, the standard language used to communicate with the database. So Edgar Code introduced the relational database model. Okay, Dr. Edgar Code is a person who has introduced this relational database model. Many modern DBMS do not conform to the core definition of RDBMS, but but nonetheless they are still considered RDBMS. The most popular things are MS SQL Server, DB2, Oracle, MySQL, PostGRS, and we also have IBM also has their own product. These are the most popular RDBMS systems. We already know that a table is a central RDBMS object. Everything in database is in table only. So table is the main thing which holds the data. Upon the table, we'll have some views, we'll have some procedures, return functions. Everything will be based upon this data. So, what is the purpose of having? The purpose of having views when there is no table? What is the view? It is a pre-compiled SQL statement. So without table, what is the necessity of having a view, procedure, functions? So, in a perfect world, you would never have to change anything in a table structure once it's created. Generally, after a table is created, you generally will not have to make changes generally, but there could be some cases where you have to change the logic. For example, I created my student table having roll number, his date of birth, mobile number, rank, etc. So ideally, I will not be able to make any changes. Generally, I don't make changes. However, tomorrow a new rule comes to add their Aadhaar card, PAN card. Only then I have to change. These are the new changes system. So earlier we are not having Aadhaar card. So we are just entering only your name, date of birth, sex, gender, and mobile number. Now we have made Aadhaar as a mandatory. So in order to add Aadhaar, you have to modify the structure. So mainly by changing the business rules, you might have to make changes to your design. That design is called the altered table statement. This altered table statement is altered table is to make changes to existing table, so that you can add some more. You can say alter also. You can modify your existing column. You can add a new column, or you can also drop a column. So these are all possible values which can be taken by the alter statement. A drop table statement is to remove a table. Both its data and definition would be deleted. Suppose you have a table which is not being used at all. Initially, you have created a table called some fees overdue. Suppose if you have something you have paid more than actual fees, then it is a fees you have created by. You thought that there might be a case where student will be paying more than actual fees, but you are seeing that the table is of no use and nobody is using that table. So you have to drop the table. So when you say drop table name, table name. Your table name is top table name. In that case, your table will be dropped. When the table is dropped, you are going to lose the structure and the data also. Structure and data is also is also lost. So mind you, when you use a drop statement, you are going to lose the data as well as the structure. Now alter is used to make changes to the existing table structure. In that alter, you can modify an existing column. You can modify existing column. You can drop a column. Or you can add a new column. You can add a new column also. Okay, fine. Designing a database requires an understanding of both the business functions you want to model and the database component features you want to represent those business functions. So if you have to understand the design, first we need to understand what is that you are going to store. First, when you want to design a database, you should know what is that you are going to store in the database. So unless you know that what is going to store, how can you design your database? So while designing a database, you need to understand of the business functions you want to model and the database concepts and features used to represent those functions. Suppose you have to store student data, then you have to create a student table. If you want to view the student data, you should create a view to view the data. So in order to understand, in order to develop a database, you need to understand what actually you're trying to do. Okay, that is the business logic. It is important to accurately design a database to model the business because it can be time consumed to change the design of the database significantly once implemented. So I'm saying that. So it says that when you're trying to design a new database, you should take sufficient care so that you're trying to use all the data. Once if you're trying to make changes, then again it is going to take a lot of time. So when designing a database, consider the purpose of the database, how it is going to affect the changes. So create a database to fit your plan. Okay. So make sure that when you design a database, you're almost taking care of all the precautions so that you don't need to make changes very frequently. Because once your database is created, to make it changes, you need to spend a lot of time. So you need to spend lot of time. So do not try to make changes every frequently. So database normalization rules that prevents mistakes in database design. Okay. So after creating the database design, then you have to implement the various forms of the normalization so that your data would be further break down into multiple tables. So that you will not lose you will not have database update and delete anomalies. The production of the data integrity, security requirements of the database and user permissions, and the performance needs of the application. This is the various things you have to consider while you are going to plan your databases. Okay, now we'll see how does this be linked with the software development cycle of the database. So in the software development cycle, it starts with talking to the customers to get requirements, and at last giving him a product so that he can use it. So it is something called as software development cycle. The software development cycle models describes the software cycle and order in which the flows are executed. It means, suppose if somebody comes to you and tells you, I want to build a house. Okay, very good. Then after that, so what we are going to do? We want to ask him, okay, what are his land requirements? What is the land size? How many bedrooms he want? How many bathrooms? And also how many bedrooms and where he wants the balconies. So all we take him. Then after talking to him, we develop a plan and we show him this is the plan. This is the cost incurred. If you're ready, we'll proceed next step. So this is not done in overnight. This is done as part of process. So there will be multiple phases. In the first phase, you talk to the customer, take his requirements. The second phase, you make it a model. You make it a model, show him on the plan. This is how. This is where. This is what. Okay. So each phase produce the deliverables required for the next phase in life cycle. So in order to go to next cycle, the first cycle has to be completed. Its input should be taken to the next cycle. So the requirements are considered in your design. So after talking to the customer, you take the requirements, you can do design. The code is produced according to the design, which is the development phase. After coding and development and the testing verifies the deliverables, it is given to the implementation. So they are following 6 phases of every development software cycle. First is the requirement gathering analysis. So you talk to the customer, you take his requirements, and you do analysis. Then you design. After the design is accepted by the end user, then you implement other code. Then you do the testing. Then you deploy, and then you do the maintenance. In the maintenance, if suppose in maintenance he says that I have made small changes, then you can done the maintenance. If you see the diagram high level, this is the first step. In the first step, you are going to do the requirement analysis. After requirement analysis, then you are going to do the design. The third step, you have the implementation. Actually, where actual coding is done here. Then the fourth phase, testing will be done. After the testing is completed, and if there's nothing to be worried, everything looking according to defined, then it goes to the last step. That is the last step. That is the evaluation. In the evaluation, actually, this is the software development life cycle. It starts with the requirement analysis. Goes to design. After design, it goes to the implementation. The implementation, testing, and the last is the evaluation. This is the software development life cycle. Okay, now we'll see how SQL Server will fit into this. Now we'll see this how SQL Server is going to fit in this. This is at a high level diagram. Okay, now this will talk about in the left side. We have seen what is the software development cycle. Now here in the next slide, in this slide, we are going to fit our database here. Okay. First is the project. Okay, step 1 is project planning. Second is present project to a bug, project specifications, development and coding, testing, final approval process, DBA to deploy production. Okay, these are the various stages. We have 7 stages here. Okay, the first step, project initiation, banner project request form filled out and submitted. That means here the customer will say that I want to do this. So he will be given on a form. This is what I am requesting from you. So he will fill the documents. He will fill the requirements. So that is the project initiation. That means you are starting your project. The project initiation, banner project request form filled out and submitted. Then initial requirements gathered. Data custodian meeting established. Resource identified. Now after this, he'll give you the requirement saying that I want to store this data. So then you will identify, okay, in order to store this data, I need this database, I need this server. Okay, they are all done in the project initiation style. Now it goes to after this approved, it goes to the second step, project approval. The present project is present project to the bug team. Further define requirements based on the bug feedback. And at this stage, this is further analyzed, and your project is sent to the bug team. Now here, in this case, this is important. This is the main step. Project document starts here. Help desk tickets opened with initial requirements. So the designs are completely defined. SDD, software design specifications, requirement to traceable matrix. This is the main phase. This is the main phase of the development of the before writing a code. This is actual part. This is the main part. This is every entity is identified, how it is related to other. Everything is documented here. Okay? And everything is that in the software development specification, you want this table to hold this. This is the maximum size. This is the how it is with other tables. This is actually the. You see here, no coding is done. Only the prototype is done. And here it is shown to the end user. If the end user accepts, this is fine. Now this is the final step of the documentation. Now after finishing this, now it goes to the next phase called development and coding. Actually, based upon your requirements, you will be writing code here, and you'll be writing code that is part of development and testing, development and coding. This also will be tested by your programmers. Once they see that it is working as per the given software, the SDD, then goes to the testing department. It goes to the testing department. In the testing department also test as per this document, and if they identify any things, if they don't identify, then it is test to the final approval process. In the staging, it will be tested by the alpha users, beta users, and if it is thing, it goes to the steps on is DBA production. Now here, the requirements are first gathered, then it is designed, then it is developed, then it is tested and is deployed. In the project testing, deployment instruction deployed to VAK for testing and user feedback. So at this phase, it is that end user testing, and also the actual user will be testing on a beta data. Okay, and the last step is the project completion. The user approval for production. Request changes submitted for change request meeting. The coordination of push to the production. Okay. We'll see what are the different levels of the database. Here, in the requirement specification, the database designing. So understand the operational business requirement organization. So in order to prepare on a document, you have to design the tables. First, we have to understand what is that you want to store. That is understand the operational business requirements of an organization. Then the conceptual database design. Express the highest level relation between the different entities. Then we have the logical database design. Express fully attributed data model that is independent of DBMS. It could be any database. First, what you have to mention that you have to totally prepare a plan that this will be there like this. Yes, after that, fully attributed data specific to the version of the data processing technology. Now here we will choose, it could be a DB2 or a SQL or Oracle. It is a physical database. In the logical database design, we will not be talking about anything of this. Okay, the logical design of the database includes the tables and the relations between them. The logical database design would define the tables and the relations between them is one of the core of an optimized relational database. A good logical database design can lay the foundation for the optimal database and application performance. A poor logical database design can impair the performance of the entire system. Suppose if your design is not correctly, then it is going to affect the performance. Suppose your data is your design is foolproof, then you will not have any problems. So the normalizing the logical database design involves formal method to separate the data into multiple data tables. So what is the normalization? Breaking the data into multiple tables. This is the normalization technique, is to break into multiple tables. So the greater number of narrow tables with a few columns is a characteristic of a normalized database. A few wide tables with more columns are a characteristic of a non-normalized database. Suppose if your database is not normalized, there would be few tables with many columns. Because you are actually trying to store everything into one thing. What is same thing if you normalize the data? If you normalize the data, your data will be distributed into many. Your data will be distributed into many tables having few columns. Okay, in the relational database design theory, the normalization rules identify certain attributes that must be present or absent in a well-designed database. A complete discussion of normalization rules goes well beyond the scope of this topic. However, there are few rules that can help you to achieve a solid database design. Every table should have a numeric or unique identifier primary column. So, when you're trying to design a table, should have a numeric or a GUID column which you identify is a primary key. Okay, a table should store data for a single type of entity. All fields must be related to the key. For example, avoid storing information about a student or in this test score in a same table. See, if you want to store a student information, so why do you want to store the marks also in the same student table? Because you'll be writing various marks. So you avoid. So you separate the table from a master student table to marks separate table. Okay, the table should avoid nullable columns, but it is not mandatory. But it is better to avoid a nullable columns. The table should also use default values where appropriate. We try to make use of the default value. For example, the date of joining of student, the date of joining of student could be the current date of joining. The highest score should be 100. So these are default values, and a table should not have repeating values or columns. For example, score 1, score 2. So this it's though it is not it is not wrong, but it is not a good design. So as the normalization increases, so do the number of and the complexity of the joins required to retrieve data increases. So as a part of the normalization, what you're doing is that you're trying to break your data into multiple tables. You're breaking your data into multiple tables. So you have to again to display that you have to display back to the user. Then you have to join all these tables once again. So in order to join these tables, you have to use joins. So complexity and the number of joins are going to increase. Too many complex relational joins between too many tables can hinder performance. Suppose if you're breaking such a minute, again you have to get it back. You have to use lot of joins, and it's going to take them. The reasonable normalization often includes few regularly executed queries that use joins involving more than 4 tables. Enforcing data integrity ensures that the quality of the data in the database. One of the more common forms of data integrity is referential integrity. So what is a referential integrity? When your tables are part of a relation, they can be linked by using the primary key and foreign key tables. This is called the referential integrity. The referential integrity preserves the define the relations between two tables when records are entered or deleted. So the referential integrity preserves the defined relation between the tables when records are entered or deleted. In SQL Server, the referential integrity is based on the relation between the foreign keys and the primary keys, or between the foreign keys and unique keys. The referential integrity ensures that the key values are consistent across all the tables. So such a consistent requires that there will be no references to the non-existing values, and if the key value changes, all the references to change and consider. So now this is very important. The referential integrity will ensure that the key values are consistent across tables. That means that I have a master table. I have many child tables: roll number, student number. Then I have a library. I have a fees table. Then I have scores. If I change the value at the one place at the primary, automatically it will be changed at various places, because all these are a part of a relation. Everything is controlled by the relation. So such consistency requires that there will be no reference to non-existing values, and if a key value changes, all the references to that will be changed. So suppose it is a accurate data. If you're storing the accurate data in the system, then you're going to get a good designs. But if you're storing some junk data or invalid data, then you might have having a bad decisions. For example, a student is there. Student, a roll number is there. Actually, for every student, will have own number. But of some mistake for that same student, you are under two roll numbers. When you print this student data, you'll be getting two roll numbers. Now you are confused, which is what, which is right, which is wrong. So this is going to give you a bad decisions. But if you make sure that every student is having only one roll number. Every roll number. If you change only a particular problem, suppose okay, in that student master, his mobile number was initially 98 something there. Now he has changed it to some 703. If you make the change at one place, automatically the change will be affected all the places. All the places. Now this is something called as referential integrity. And the beauty of it is that if you make change at one place, rest all changes will be affected. When you design a database, you must ensure the database performs all the important functions correctly and quickly. So when you design a database, you should okay when you design the database, you must ensure that all the database performs all the important functions correctly and quickly. The some performance issues can be resolved after the database is in production. Okay, if there's some performance and if if your DBA thinks that something can be sorted out, he can make changes. But the performance done by a poor database design, sorry, not pure, poor database design, it can be changed only by changing the structure and the design. Suppose your function is using very slowly, and you think that you could draw further background in the normalization. Then the speed then at that time you have to change the structure. That is very bad and very costly. When I say costly, because already your data is in production, you already have live data. Again, if you are going to change the structure, you have to make sure that your data is not lost. When you design and implement database, you should identify the large tables in the database. When you design and implement, you should identify the large tables in the database, and then the more complex the data is going to perform. Give a special consideration to the performance when designing those tables. Also consider the effect of performance of increasing the number of users accessing the. Suppose initially there might be only 10 users. Tomorrow, if you get 100 users, then load is going to increase. It. You have to think in well advance, like how many features can we expect. If you're storing all into one table, it could slow down. Okay, that in conjunction with the correct database design, correct use of indexes is important to achieve good performance. So when you are trying to design a database, you should also think that how frequently is the most properly used column. For example, all ticket will be generated every 6 months. Every 6 months they will be entered in the marks table. Suppose you have to display all these things. You know that every 6 months I'm going to have my data coming in the marks table. Well, there could be additional load on the marks table. Again, there could be a semester exams or a mid exams. So or Viva labs. So you have to create indexes based on the things. The last slide. The index in a database is similar to the index in books. So if you see any book, if you go to the last page, you'll see at this page number, I can see this topic. So all the topics, all the important topics will have some number assigned, the book page number. So in a book, an index allows you to find information quickly without reading the entire book. You don't need to, if you want to find a particular topic in the normalization, you don't need to read the entire book. Just go to the last page where this is index. You see the page number, directly go to the thing. So in an index and in a database, an index allows the database program to find the data in a table without scanning the entire table. An index in a book is a list of words with the page numbers that contains single word. An index in a database table is a list of values. In the table, there is the storage location of the rows in the table that contains each value. Like a book, when so at this page, this is there. Same way, when you create an index, automatically a pointer is created. Directly, when you ask for this record, directly a D will go to that record and get the data. Indexes can be created on a single column or combination of columns in a table. An index contains an entry with one or more columns, each row in the table. But this is about indexes. No, these are all the various things you have to consider while designing a database. First, you have to consider the database performance by using the index. then you'll have to make sure that you follow the correct normalization. If you use the correct system, correct data, you're going to get the correct decisions. If you use some wrong data or invalid data, you're going to get a bad decisions. Then you have to design your tables correctly. Use the normalization, and this is the most important cycle. So before actually starting any database development, first identify the requirements. Then you prepare on conceptual database design. Then after that you create a logical database. So this is independent of any RDMA system. At last we have the physical database design. Okay. Thank you. Have a good day.
Like, share and subscribe. Hit the bell icon for more updates.